Okay, in this video we're going to use the laws of logs to simplify some expressions. So the first one is log to the base 3 of 9x. And to simplify this, I'm going to use the first law of logs, that log to the base a of the product of x and y equals log to the base a of x plus log to the base a of y. So in this case, I've got 9 times x, log to the base 3 of 9 times x. So I can say this is log to the base 3 of 9 plus log to the base 3 of x. Log to the base 3 of 9 is equal to 2, and log to the base 3 of x I can't do anything with, so I'll leave it by itself. So log to the base 3 of 9x is 2 plus log to the base 3 of x. Another example is log to the base 2 of 3x divided by 8. For this expression, I'm going to use my second law of logs, and that is log to the base a of x divided by y is log to the base a of x minus log to the base a of y. In this case, my x is 3x and my y is 8. So this becomes log to the base 2 of 3x minus log to the base 2 of 8. I can't simplify log to the base 2 of 3x. Well, I could actually use the first law of logs. So let's do that in a moment. But I know log to the base 2 of 8 is going to be equal to 3. So now if we go back to this first law of logs, we can say log to the base 2 of 3x is log to the base 2 of 3 plus log to the base 2 of x, and we're still taking away 3. Now log to the base 2 of 3 is not going to be a nice number. If we put that into our calculator, log to the base 2 of 3 gives us about 1.58496, and take away 3, we get log to the base 2 of x minus 1.42 to 3 decimal places. 3 significant figures, sorry. Look at another example, log to the base 3 of 9x squared. Now, we're going to use the power law of logs, our third law, but we need to be careful here. We haven't got 9x all squared, we've got 9 times x squared. But we can say that this is log to the base 3 of 3 squared times x squared. So this is log to the base 3 of 3x all squared. Now we can use our power rule, and we can say that this is going to be equal to 2 times log to the base 3 of 3x. Let's just put brackets around this, because now we can use our first law of logs on log to the base 3 of 3x, and we can say that this is 2 times log to the base 3 of 3 plus log to the base 3 of x. Log to the base 3 of 3 is equal to 1. This comes from this law here. Log to the base a of a is equal to 1. So we get 2 times 1 plus log to the base 3 of x. Expanding out, we get 2 plus 2 log to the base 3 of x. So let's do a few more examples. If we've got log to the base 3 of 4x plus log to the base 3 of x, we can use our first rule, and we can use this in the reverse manner now. We can say that this is log to the base 3 of 4x times x, which is 4x squared. And we can say that this is log to the base 3 of 2x all squared. So this is log to the base 3 of, 2 times log to the base 3 of 2x. Our final example involves using the change of base law. Here we've got two logs to two different bases. So what we're going to need to do is change one of the bases using this law here. So I'm going to change the base of log to the baseline of 3x, so we have a base of 3. So I'm just going to do this working here on the side. Log to the base 9 of 3x. Let's compare this to the law. We can see that our 9 is going to equal a, and our 3x is going to equal x. And we want our new base, b, to be equal to 3. So we can say that this is equal to log to the base 3 of 3x over log to the base 3 of our original base, which is 9. So this is actually log to the base 3 of 3x. Log to the base 3 of 9 is 2. So putting this back into our original equation, we get log to the base 3 of 9x plus a half times log to the base 3 of 3x. Using the power law, we can rewrite the second log as log to the base 3 of 3x to the power of a half. And if we wanted to, we could use our first law to combine these into one log. 3x to the half is root of 3x, so we end up with log to the base 3 of 9x times square root of 3x. And we could write this as a simple single power of x. It is log to the base 3 of 9 root 3 x to the power of